Now splitting codes should have special properties, right? So the first of all, or the most important part, is they should have random-like properties. Okay, so it is known that a random noise does not have a DC component. So to avoid having a DC component, the number of zeros and ones or minus ones and ones should be the same, approximately the same. So when we have this property, it's called the balanced property of the code, right? The number of consecutive ones or zeros is called a run. Small runs are desirable in spinning codes, and this leads to better synchronization at the receiver. If you have a long run, I mean long number or a large number of consecutive ones or zeros, maybe the receiver synchronization will drift, and then you'll get a problem in the synchronization. So asymptotically, in large sequences, we have half of the runs are length 1, so we have only 1 1 or 1 0. The quarter of the runs are of length 2, and so forth. Okay, so such a property or such conditions are called the run property, and there's a property for pseudo-random codes or space spectrum codes. Okay, and another important property is to have autocorrelation function. It should approximate an impulse. So a code first having the above properties is called a pseudo-random code. Okay. Now, how do we produce such codes? We use shift registers. Okay. Now, there's a subset of pseudo-random codes called maximum length codes that are generated with shift registers having n stages. Okay, and such registers or such construction will lead to a code length of n equals 2 to the power small n minus 1, and the period will be n times the chipping period, right? So we have here the shift registers, right? And this is what it will be XORing logic to produce the input bits here. So I mean, this logic will create different codes. So different connections here will lead to different codes and different types of codes. So the autocorrelation code for the maximum length codes is given by equation 12. As you can see, when n goes to infinity, this term goes to 0, and this term goes to 0, and this will resemble an impulse, right? As for the spectrum, as n goes to infinity, this sink will become very wide, and this will reduce down to sorry, to 1 over n, right? So this is the autocorrelation function of the PN code or maximum length code, right? And as you can see, it's periodic here.